No, because it's like sorry.
Okay, that's fine. Derivative.
Yeah, I know.
Okay, derivative of a constant function. Well, a constant is not changing, right? For example, take y equals 3, right? What does that look like? It looks like a line here, okay? Well, when I'm asking for the derivative, we're thinking of the slope. Well, what's the slope of a horizontal line? 0. So therefore, the derivative of a constant is 0. Therefore, d dx of 3 is 0. Okay. Easy peasy.
Lemon squeezy. One might say.
All right. So d dx of pi would be 0. d dx of square root of 6 would be 0. So d dx, remember, d dx is just a way to say the derivative with respect to x. We'll talk about that variable on the bottom. But for now, just remember it means slope. Okay, this is the one I already showed you. So now formally, we are going to introduce the power rule. So the power rule takes whatever the exponent is, moves it in front, and we reduce the exponent by 1. So our example here, if we take the derivative of x to the 5th, it's going to be 5x to the 4th power. Cool. All right. Let me know if I go too fast. Hopefully that kind of semi-introduced. So, all right, constant multiple. This is also known as when you have a coefficient. Okay, so whenever we have a coefficient, meaning just the number in front, we can move it in front of the derivative. So, for example, if I want to take the derivative of 4x squared, now I'm going to show you moving 4 in front. Normally, I would not show this amount of work because it's usually pretty intuitive. What would be the derivative of x squared? 2x.
Times 6x.
So times 4. 8. This is way more work than I would normally do. I usually would just look at this as multiplying the 2 to the 4. Okay. But you are utilizing that constant multiple. Good. Oh, let me know if I'm... Okay, sum and difference. Now, what I want you to remember, this is, once we go, learn all the shortcuts, I don't want to say don't forget about that limit definition. It will come back from time to time. But all of our derivatives are based on limits. So remember all the rules that apply to limits. So for example, we had a problem like sine of x, or actually here, let's make that infinity. Like something like this. What were we able to do with this function? We were able to split it up into 2 parts and then find the limit, right? We were able to do the limit here. Right? And then we were able to evaluate the limit of each part. So the same thing when we have a derivative. You can just do, for example, if I take the derivative of this, I'm going to think of each of these separately. So I'm going to do, what's the derivative of 4? 0 and 15x squared. So I just get 15x squared. So again, you kind of do that just intuitively. You don't really think about doing it. You just take each part separate and do each derivative. Okay, let's do some polynomials here. I'm going to try this one. Okay, so if it's a fraction, you can either think of that as a half, or move the 2 in front, so that would be 2x to the first over 2, so the 2's will. So here, okay, so let's go through. So dy dx. You could put y prime. It doesn't matter. There's different notation I'll use. Did we get 12x cubed for the first part? Minus 18x squared plus minus 1/3, because think, right? That's technically a minus 1/3 coefficient. And then the 10 is the constant, and remember that's just going to go away. That's just going to be 0.
Wait, how do you spell x squared over 2? Sorry.
So if I was just doing the x squared over 2, that would become 2x over 2, which would give us x. Right? Because just think, what's x squared going to become? 2x to the first. Remember, the 2 goes in the front.
Oh, okay.
Yeah, so this is really...
Oh, so you only do like the top and then like the bottom already.
Yeah.
Okay.
The denominator is not going to change. So whenever we have that coefficient, I usually say, we just bring that constant, that coefficient along. All right.
How do you do the 1/3?
So think about it being a negative 1/3 x. What would the slope of that line be? Negative 1/3.
Then what's the 1?
Oh, I just put the 1 in front because when you divide something by 3, it's the same as multiply. Just to kind of think of it as a coefficient of negative 1/3.
Stop.
It does.
It's us. No, it smells like gas.
So they were leaf blowing or something earlier outside.
I thought you said it smells like eggs. No. Eggs. It just smells like gas.
You smell like spoiled milk.
You smell it outside?
No, I didn't smell it. I just smell vanilla.
Yes.
Don't want to. I wish I smelled. Wait.
Okay. All right, we ready? I'm going to use this time. I'm going to write a y prime just for extra.
Does it matter which one we do?
It doesn't matter. So we have our 2 calculus old white guys, Newton and Leibniz. Okay, so they just use different notation. You just have to be familiar with both. Newton used the y prime. Leibniz
I
used.
just took them off. And I didn't even take them completely off. I'm just like.
Okay, let's see here. What do we get for 3? Well, what happens when we take the derivative of 3? 0. So that'll be a minus 6x to the 5th plus.
X cubed over 2.
Good. Okay. Now. Yeah, so think about if this was y equals.
If it was like 5x.
What?
10x.
Yeah, when you get down to something like this, think y equals 7x would have a slope of 7. Or you can use the power rule, because if you had 7x to the first power, right, it would become 7x to the 0, but that was
7 times 1. Okay.
which is 7. Okay, so you can either think of it as what's the slope of that portion or use the power rule. Now imagine if we had to do the limit here. That would be not fun, okay? Because that would be nearly impossible to do. It would take us probably all period just to figure out. So that's one of the beauties of the shortcut, okay? Same thing with this next one. So it says find the horizontal tangents. Okay, horizontal tangents have a slope of 0. That is when our slope is 0. So then we want to find when dy dx is equal to 0. Okay, so y. Right, so first we're going to do the derivative. All nice little power rule here. So 4x cubed. Good, minus 4x, and the plus 2 goes away. That becomes 0. All right, so dy dx. So before I set it equal to 0, you'll notice I usually leave the dy dx in there. I'll set it equal to 0 after I factor it, just because later on when we have to analyze the graph, it's good to have what our factored form for dy dx is. So what can I take out of 4x, and I'm left with x squared minus 1, which becomes perfect. Okay, so find the horizontal tangents. Okay, so first of all, this will tell me what my x values will be with my horizontal tangents. So this will have horizontal tangents at plus or minus 1 and 0. Now, what was the question asking for?
The horizontal tangent.
Okay, so I found out where the horizontal tangents, but if we're actually finding the horizontal tangents, that would be a y equals. So how would we find the equations of the tangent lines? Plug it back in. Okay, so what happens is if I plug in 0, okay, so y equals 2 is one horizontal tangent. And does it matter if I plug in positive or negative 1?
No.
No, because we're squaring and taking to the 4th power. So what happens when I plug that in? 1? Good. So y equals 1 and y equals 2. Those are the horizontal tangents. Sometimes I might ask you where they occur. Where they occur are always going to be x values. What the actual equations are will be the y values. Good? Okay. It's not. Okay, we have a couple rules today. Product rule. And we have our quotient rule. Cammy, no spoilers.
This one's actually not.
This one's not bad. This one's not bad.
I like the song though.
Okay, the quotient rule has a nice little rhyme to it. I don't have anything fancy for the product rule. Okay, I like this form. These are the same thing. They're just different formats. So if you have two things multiplied together, okay, I can't just do the derivative in one part and the derivative of the other part. What I have to do is I take the derivative of the first part, keep the second part the same, and then I'm going to keep the first part and I'm going to multiply by the derivative of the second. So it's kind of like we just take turns. You'll see here. Okay, now normally I could FOIL this out and then I could just do power rule. But for purposes of the power rule or product rule, excuse me, I want to make this my U and this my V. Okay. Now, according to my derivative, what would U prime be if U is 2x plus 1? 2. And what would V prime be?
3.
Yes. Okay. Now we're going to apply our product rule. Okay, so U prime. So the derivative of the first part is 2.
2 times 3x.
Good. 3x minus 5. Always a plus sign in between, unless, of course, one of those other values is negative. And now U is 2x plus 1 times 3. Let's go ahead and multiply that out, and then all we need to do is just combine like terms. So that's going to give us 6x.
12x minus 7.
Okay. 12x minus 7. Tuesday, I mean. Oh my gosh.
Don't say that.
Call me Monday. Oh my gosh. See, this is what
Tomorrow's my last day of the week.
I keep getting the class periods mixed up because for like the last 3 years, I always had geometry honors during C period. Now I have a D period, and I keep getting thrown up. I was like, "Oh, I don't see you tomorrow," and they're like, "Yeah."
You don't see us tomorrow.
I was talking about my D period, which I do have D period tomorrow.
Wait, what?
Oh, I
forgot.
never meet. I feel like this class never meets.
It's a shame. It's a shame. It's okay.
So behind. Our essence Thursday.
Okay, now for the fun
That's a
one.
week behind us.
Not that the product rule wasn't fun, but this one has a nice little one. Okay, so now we're going to do the quotient rule. So here it is. Okay, what we do is we take the denominator. Okay, so here's the rule. We take the denominator times the derivative of the numerator minus, we take the numerator times the derivative of the denominator over the denominator squared. So, okay, it's not really a song. I mean, maybe there's a, did you guys sing something?
Wait, how do you do it?
Okay, you just kind of, it's like a little rhyme. It's like low D high, take high D low, cross the line and square the low. So,
you go to like low, high, take high, D, low. We made it like a little country, you know?
Oh.
Yeah.
Now I gotta hear the
high, D, low, cross the line and square the low.
There you go. I like it. I like it. Okay, now what does that even mean according to, so low, we think of the denominator. Okay, I promise you, some of you are like, I'm just going to memorize the formula. Great, just memorize the formula. I promise you. You're going to eventually get the low D, high take, high D, low, cross the line and square the low because it just
wait, what is
flows.
Low,
So,
high, take, high, D, low.
Okay, low means the denominator. Okay, the denominator is our D. D high, so that means take the derivative of the top, which is our numerator. Okay, so we take the denominator. So, sorry, I'm kind of abbreviating here. So low means the denominator times D high, derivative of the numerator. Take means minus high D low. So now I'm taking the numerator times the derivative of the denominator. Sure, that's what I said. Go for it, but I promise you, you're gonna get used to it. Okay, cross.
High, take high, D, low, cross the line and square the low.
Cross the line.
Like you know it's a beautiful song if I still know it.
And take the denominator and square it.
I still know that. X equals
Negative B plus or minus square root B square minus 4AC all over 2A.
Yay, okay. All right, so so you know that song. You'll remember the low D high take. Okay.
I'll sing it to you before you go to bed every night.
Just make sure you remember what to start with. So some students will forget to start with low. I'm like, no, you have to start with low, D high, take high, D low, cross the line and square the low. Okay, low means take the denominator. D high, low D high. So derivative of the top, 2. Minus, take means minus. Low D high, take high D low. 2x. Yeah, the derivative of the bottom, that'll just be 1. Cross the line, that's our fraction line, and square the low. Now, I'm not going to bother multiplying out the denominator. I am going to leave the x minus 4 squared. So let's just combine what we can in the numerator. So that's going to be what? 2x minus 8. So just negative 8. Oh no, another one. My goodness.
At least mine are no, I'm very interested.
Okay, here we go. Okay, low D high. So low is x minus 1. D high, derivative of the top. Okay, so now derivative of x, so 2x plus 4. Take high D low, so the top. Oops. There we go. Take high D low, so that's just 1. Cross the line, square the low. Again, don't multiply out the denominator. Leave that as x minus 1 squared. Let's just see what we can simplify in the numerator. Yeah.
Oh. Okay, I was like a little behind. The bottom I understand, like that you square the bottom. How do you do the first part? The x minus 1 and 2x plus 4?
Oh, so low D high. So we take the low means take
So just
the bottom.
The denominator, don't do anything to it? Okay.
Yeah, don't do anything.
Okay.
D high, so that means take the derivative of the top part.
2x
plus 4.
Oh, okay.
Take high
Without doing anything.
without doing anything. D low, so derivative of the bottom, well, that would just be 1.
Yeah.
Cross the line, square the low.
Okay. I think that was.
Okay.
I got it. I just needed to go through it.
Got it. Okay, so we would have a 2x squared and then minus an x squared, so an x squared. And then what? Minus.
Wait, minus 4. Wait. It's 2x squared.
Well, no, 2x squared minus x squared.
Yeah.
Oh, sorry, I was combining everything in one step.
Yeah. It's x squared minus.
Do you want me to do it 2
minus
steps?
4 plus 6.
If I skip,
Yeah, no,
do you want me to? I'll write it out. It's fine. Sometimes I tend to skip too many steps, so there. I'll multiply that above. Okay, now we're okay with just the x squared. Yeah. And then it's going to be minus 2x minus 4.
Oh.
Use as many steps as you like. Just
Can we leave it like that? Or
leave it like that. So you can try to simplify, meaning could you factor out the numerator and cancel?
Yeah.
It's possible, but this will not factor into anything. So that's why I said usually just leave the denominator. Most likely it's not gonna factor anything nicely. Okay, power rule is power rule. The rule does not change regardless of whether you have positive or negative integers. So you'll see the rule is exactly the same. Doesn't change. So if I have 3x to the negative 4th, we just have to be careful. We get, okay, so negative 12.
negative 5.
Good. So it depends. If I ask for it in simplified form, then I want you to just change any negative exponents. Also, when we have to evaluate, obviously leaving a negative exponent is not as easy to evaluate when we're plugging in numbers. So, okay. Also, most of the time, you won't be originally given a negative exponent. You would be given something where it's like 1 over x cubed, but we want to be able to first, we'll rewrite it. So, yeah, so this is x to the negative 3. Now we want to find the equation for the tangent line at the given point. Now, some of you got a little stumped on the one question on the quiz. And remember, a line tangent is just point slope form. Y equals y1 plus m times x minus x1. Now, I'll always give you an x value, at least. Okay, on the quiz, I happen to give you an x, a y, and the slope. I gave you everything. But for this one, we have x1. That's negative 2. Right, so this is m is going to be f prime of negative 2. So from here, what's f prime of x? Negative 3
over negative x.
Yeah, so we have to be careful that negative 3x to the negative 4 or negative 3 over x to the 4th power. Okay, so I have an x1. I have a formula for the slope. I need to find y1, and I need to find my m.
Wait, you just found that.
Well, so if I have x1, I could just plug that in to find y1. So if I plug in negative 2, that'll give us negative 1/8. Okay, so this is going to be my y1. And now my slope is going to be f prime of negative 2. So there's kind of 3 components here, right?
So you plug it into the negative 3 over x.
Yeah, so notice For this one, to find y1, I'm plugging into here. To find f prime, I'm plugging it into here. So that'll be -3 over -2 to the 4th power, which is -3/16.
And that's n.
And this is m. So right here we have our m. So it's going to be y equals -1 over 8.
Plus or minus 3 over
Good. Times x plus 2. Again, please don't bother putting this in slope-intercept form unless you really, really, really want to, but
Would you
not at all.
Okay.
In fact, this one isn't too bad because you would end up with a common denominator. And then what it would cancel, but, right, you would have a -3/16 plus 8 minus 1/8. You don't need to do that though. Good? What's wrong? Oh, I did. Oh, yeah. Sorry. I missed this one. Okay. This one, we actually have 2 different ways that we could do this. We could do the quotient rule, or I could simplify this, and then I could do the power rule. You want to do quotient rule? It doesn't matter. Maybe quotient rule is a good practice, so let's do that. Okay. Low, D, high. That's it. So
Wait.
low.
Do we have to write like y prime at every step? No, right?
Do I have to?
Like you don't have to write dy, like how you have to do limit for every step. You don't have to do it with this, right?
No more limits here.
No, but like
Oh.
in front of everything.
I'm gonna always label it y prime or dy dx.
But like for the first one, yeah, but like for every step.
Oh, as long as you just like equals, then it's fine. Okay. It's implied this is a limit.
Mm-hmm.
So I don't have to keep writing limit each time. So our implication here is this is a limit. It's like I don't have to keep writing that. Yes, Yali.
How do you know like what to use for each problem? Like, which makes sense.
Well, you have to look. Okay, this one here, let's say you forgot you could change it into a negative exponent. You could have done the quotient rule here, and you'll end up with the exact same answer at the derivative at the end. So sometimes it's like there's more than one way to find it. It just depends. Like there's a lot of things in math where there might be 2 different ways to get to the same answer. One way might be a little bit longer than the other, but we should end up. So like if you have a fraction, you can always do quotient rule. Okay. Here I can rewrite this to make this 1/2 x plus 3/2 x to the -1. That's how I would rewrite this, but a lot of students wouldn't recognize that. They would say, just do quotient rule, which it's fine. We're going to end up, it might look different in my original setup, but like when we plug in, we're going to get the same answers. Okay. So we have low 2x, d high 2x, right? Take high, x squared plus 3, d low, 2. Cross the line, square the low. No.
Yeah, no.
Wait.
No.
Well, okay, we have a 2x here and a 2x here, but we would need to have a separate 2x here in order to cancel. So I'm gonna leave it. I'm gonna just simplify the numerator and leave the denominator. Okay, so this is gonna be 4x squared minus a 2x squared to 2x squared.
4x squared. Oh, but so
Sorry, I'm skipping my.
No, you're good.
Okay, and then minus 6.
Yeah.
Cool.
Over 2x squared. Would you?
I wouldn't bother simplifying. Here's the thing. I want to just plug in 1. Do I want to get into business with canceling stuff when I don't really need to. Isn't it really easy just to plug in 1 at this point?
Yeah.
Yeah. So I would do, okay, so I'm running out of room here. Let's see. Let's do y prime of 1. Okay, so taking that derivative and I'm plugging in 1, that will give me my slope. We have to go back and find y1. Well, what happens if I plug in 1? I'll just get -4 over 4, which is -1.
So you wouldn't.
You see how easy it was not to have to worry about simplifying and just plug it in. You'll be less likely to make mistakes there. Okay, how about our y1? So y of 1. So plug back into the
2.
original. So that's going to be 4 over 2 is 2. So my tangent line is going to be y equals 2 minus 1.
But minus 1. But you add.
But then it'll be y1 plus m.
Oh, okay.
All good. Again, if you didn't put the 1 there, I don't really care. If you want to distribute, go for it. Okay. Oh, we're good on time. Okay, last thing here. Okay, you can take multiple derivatives in calculus and physics. Okay. Generally, we won't have to do more than like 3. In Calc 2 or Calc BC, you do lots more, like multiple derivatives. So just look at the different notation here. Y prime, that's the first derivative, or dy dx. That's the first derivative of y with respect to x. The second derivative, we just put an extra tick mark. And it looks like this. It's the second derivative of y with respect to x. Okay, notice where the 2's go. And then with 3 is the third derivative. And then anything past 3, we just put in parentheses. So if I say, what's the 7th derivative? You'll just say y with the 7 in the little parentheses. Okay, so our goal is we want to find the first 4 derivatives of this polynomial. Okay, so we'll start off with the first one. Okay, so x cubed becomes 3x squared minus 10x, and the plus 2 goes away. I'll go with the second derivative. 6x, good. So we just take that previous answer, and now the third derivative is just 6. Now, fourth derivative is where we're going to put the little 4 in parentheses. Yeah, so if it's a constant, it's just going to become 0.
And it's just 0.
It's just 0 from now on. So if I said, what's the 10th derivative, it's just going to be 0.
Okay. The first one is average velocity.
It's different.
No, it's position. Then it goes